Good afternoon, everyone. Welcome to the Summer 2020-2021 Climate and Water Update webinar. For those joining us for the first time, welcome. And for anyone who has joined us for our webinars before, welcome back. Today, our experts will be giving you an update on temperature, rainfall, and water conditions so far this year, and then we'll turn our attention to the outlook for Summer 2020-2021. My name is Jordan, and I'll be your moderator today. I'm joined by Claire, who you heard her lovely singing earlier. She'll be producing today's webinar. Together, we will help make the webinar as interactive as possible. So before I start, may I ask for your attention as we cover off some housekeeping items. So with the current situation as it is in Australia and the world, this webinar will be conducted from our respective homes. Please bear this in mind as we may encounter some technical issues during the broadcast. Our broadcast today will run for 60 minutes with plenty of time allocated for questions. And Paul's just jumped onto the Q&A section and asked he won't be able to be here for the whole webinar, so will the recording be available? Yes, it will be. It's going to be recorded and the video will be shared with you via email. So for first-time webinar attendees, please see some helpful tips on your screen. Most importantly, please note the chat box where you can send through any questions or feedback for the presenters. Please use this and not the Q&A box. It's rare that we are able to check that to send your questions to us during the session, and we will answer as many as possible during the allocated breaks. It is the speech bubble button on the right hand of your screen, and the icon will turn blue once it's on. You can see it on the slide there. If you want to test out the chat now, feel free to tell us your name and where you're dialing in from. And finally, I'm delighted to introduce you to our presenters from the Bureau. We have Greg Browning and Fatima Mechanic. Hi, guys.
Hi, Jordan.
Hi, Jordan.
So Greg has worked at the Bureau of Meteorology as a weather forecaster and more recently as a climatologist. While he has a broad knowledge of meteorology, his specialization is in tropical weather and climatology, having worked in all three of the Bureau's tropical regions, including 10 years at Darwin. Fatima has worked at the Bureau of Meteorology as a hydrologist. She has an interest in exploring the effect of climate models on hydraulic forecasting and hydroinformatics. So welcome, team. We're really excited to get to what we have today because it's such a packed hour for you. Here's the overview. We're going to have the spring wrap-up. We're also going to do a water update. We're going to talk about climate influences and then do the summer outlook. Let's not keep you waiting any longer and get straight to Greg. He's going to start us off with a wrap of the past few months. Don't forget, though, from now until the whole end of the presentation, you can send us your questions at any time. So start sending them through now. Click the chat button down the bottom and send in anything you want to know, and we'll answer them in the upcoming breaks. We have 3 of them today. All yours, Greg.
Thanks, Jordan, and hi, everyone. So I'll start with just a quick spring wrap-up. Just look at the rainfall and temperature, and then Fatima will follow up with some information regarding soil moisture and water storages. So rainfall during spring. What you see there is a map of Australia. Blue colours on the map indicate areas that had above average rainfall. The red is below average rainfall. And if it's white, it means it had close to average. So you can see it was a bit of a mixed bag. Some parts, particularly South Australia, saw some above average rainfall. Quite dry in southeast Queensland as well as parts of southern WA, and there are a few wetter patches up in the northwest as well. Overall, Australia ended up with about 6% below average rainfall. So we had a pretty good start to spring, but November, as everyone knows, was particularly dry and brought that overall number down. Temperatures, very warm spring, so it was more than 2 degrees above the long-term average. This map doesn't have too much of the blue colours, which would be below average, but with lots of orange colours, which are indicating above average, and that darker orange is the highest on record, so quite a lot of Northern Australia saw some above average or record high maximum temperatures. Australia overall was 2.1 degrees above the long-term average, which is the 5th highest on record, and the Northern Territory had its highest spring on record, and every other state saw numbers in their highest top 10 in over 100 years worth of records. Minimum temperatures, similar story again, but this time for Australia overall it was actually had the highest minimum temperature on record for the spring period, 1.9 degrees above the long-term average. Victoria, South Australia and Northern Territory all had their highest on record, and every other state finished in the top 5 of records. And with the high maximum and the high minimum, the combination, which we call the mean temperature, was also highest on record. So Australia had its hottest spring on record with more than 2 degrees above average when you put the minimum and maximum together. Just a bit of a longer term picture of the rainfall situation. So while spring was close to average, I'm sure everyone is aware that we've been in quite a dry period in Australia. So that big map there is looking at rainfall since the start of January in 2017. That's pretty much when the current drought really got started. And you can see since then, even with the rainfall that we've had this year, some parts of Australia are very dry. So that darkest red is indicating the lowest rainfall they've had in that period on record. So parts of southeast Queensland and also other parts of southeast Australia and in WA have seen a very dry period for that 3 years. On the bottom left, it's just looking at the more recent rainfall. So even though some parts of Australia have done quite well, still seeing deficiencies in the shorter term over southeast Queensland and particularly Western Australia, which is very dry in the southern half. So just setting the scene, and we'll talk about this a fair bit more, just to have a bit of a primer on the La Nina climate driver. So people have probably all heard about that recently. So we are currently in a La Nina phase of the El Nino Southern Oscillation. It's a natural cycle related to temperature and wind patterns across the tropical Pacific Ocean. La Nina is one of the 3 phases. So there's La Nina, there's El Nino, and there's neutral as well. But you just look at that diagram on the left, that's an idealized version of what happens when La Nina develops. And we see a lot of cool water across the central and eastern Pacific, extending from South America towards the date line. And if that sustains, goes for long enough and gets cool enough, it actually changes the wind patterns above the equator. And so what you can see there with those arrows is a bit of an idea of what happens with the wind. So we push more wind towards Australia, so that's a strengthening of the trade winds, and that actually piles up warm water around northern Australia. So the typical thing during La Nina is we have cool waters in the east across the Pacific and warmer waters across Australia, and that encourages upward motion and extra moisture and rainfall over Australia. So that's why when we're in a La Nina phase, we normally expect above average rainfall. And if you have a look on the right-hand side, that's the current observations of sea surface temperature across the Pacific. So you can see that big area of blue in the eastern and central Pacific, and we've got warmer waters indicated by the red around Australia. So we'll talk about La Nina a little bit more, but that's basically just a quick little nuts and bolts description of what La Nina actually is. And with that, I'll hand over to Fatima.
Thanks, Greg. I'll be giving you an update on the soil moisture and storage levels in these slides. Excuse me. Looking at the soil moisture condition across the country, you can see that there are 2 big maps on the top of the screen that shows soil moisture for 2019 and 2020. There are also 2 smaller maps at the bottom of the screen, which shows the respective rainfall. So looking at the rainfall for January to November 2019, which is the lower left map, you can see a lot of red areas across the country, which shows the very much below average conditions that we had in 2019. This below average rainfall reflected itself on the soil moistures, and looking at the top left soil moisture map for January to November 2019, you can see a lot of red area across that map as well, which shows the very dry conditions that we had during that period, except for Queensland, which we had a bit of wetter soil moistures compared to the rest of the country. Now, we did receive a bit more rain this year in 2020, and it made the soils a bit wetter. So looking at the top right map, which is the soil moisture for January to November 2020, you can see a lot of white area across the country, which shows the average soil moisture conditions. There are also some blue areas across southeast of the country in Tasmania, some blue patches scattered across the country, which shows the above average soil moistures. However, the western part of the country is still pretty dry and pretty red in terms of the wetness of the soil moistures. Now looking at the water storages, if you look at this slide, you can see that there are few buckets. Each bucket shows the collective storage volumes of all major storages in a particular drainage division. There is also a red line on each bucket that shows last year's storage level. And as you can see, the received rainfalls and the wetter soils that we did have this year have resulted in increase of storage volumes across some of our drainage divisions. For example, looking at Murray-Darling Basin, you can see that the water storages in that basin are sitting at 60% full, which compared to last year, which was only almost 38% full, is a good improvement. The northern basin, however, it's still pretty low, sitting at 25% storages being full. However, compared to last year's water level storages at that area, which was only 5%, it's still a good improvement. What we need to keep in mind is that the northern basin does not have a particular filling season, especially winter might not be the best time for the northern basin to receive enough water. So with any spring rainfall or any summer rainfall, there is still a chance of the storages in the northern basin to fill up. The southern basin in Murray-Darling Basin, however, is looking much better. It's sitting at 72% full compared to last year's storage levels, which was only 48%. One reason that the southern basin is having higher storage volumes is because winter is typically the filling season for the southern basin. And also with good amount of rain received this year at the right time, the release for irrigation for the southern basin has been a bit delayed and just started. So the storage levels at the southern basin are higher. Now, another area that the storage levels are looking much better compared to last year is the eastern coast of New South Wales, which the storage levels are sitting at 81% compared to last year, which was only 47%. The southwest part of the country, unfortunately, the storage levels are still very much the same as last year because of the dry conditions and lack of rainfall. I'll be handing to Jordan now.
Awesome. Thank you so much, Fatima, and thank you, Greg. Excellent start there. Plenty of information to take in, but we thought this would be a perfect time for you guys to get your questions in. So if you have any questions, put it in the chat function now. It's the little speech bubble button on the bottom right of your taskbar. Send them through. We love answering them. We're going to get to the first one, and Fatima was just talking then, so I'm going to bring her back. Sally has asked, what does the rainfall outlook indicate will happen to water storage levels in the MDB? You touched on it a little bit. Would you mind going into it a bit more?
Yeah, sure. Thanks, Sally, for the question. As I mentioned, the northern basin still has a chance for the storage levels to be filled. And it has missed on the recent rainfall. However, with any outlook of average to above average rainfall, there is still a chance that the storage levels in the northern basin will be filled. The southern filling season is over, but we just have to wait and see what happens if any rainfall comes in.
Okay, excellent. Let's have a switch over to Greg. A few people want to hear some of those big picture questions. Chris wants to know what are factors, if you could outline the factors, of why Queensland saw such a dry November compared to what the long-range models had forecasted. Was there influence of SAM or MJO or surface or mid-level ridging? What answer can we give Chris?
It's a good question. So partly it's a natural variability. So while La Nina on average leads to above average rainfall, it won't for every month that it's happening, and it doesn't do it every time it happens. So I think historically about 12 out of 18 La Ninas have led to widespread rainfall across Australia. So it's no guarantee. But we do have a fair idea of what the specific factors were during November. And a lot of it was related to shorter term climate drivers. So as you say, things like the SAM or the Southern Annular Mode, and the Madden-Julian Oscillation, which seemed to be probably the most significant. And it basically stalled in a region that is unfavourable for rainfall and the right sort of atmospheric conditions for above average rainfall over Australia. And it actually acted to break down parts of the La Nina. So by weakening the trade winds across the Pacific, it stopped the cooling in the ocean, and so that weakens the whole atmospheric circulation associated with La Nina. So we basically had a protracted period where some of those shorter term climate drivers were fighting against La Nina, and they basically won. And you're doing that on top of also a warmer world, and so that heat that has been a feature so much over recent years just basically came back. It was like it wasn't being held down well enough by La Nina for a period, and it bounced back. So we saw very warm and dry conditions during spring. The good news is those shorter term climate drivers look to have gone away, and we are seeing a rebound in the temperatures across the Pacific Ocean, so further cooling, and we also have evidence that the atmospheric circulation is starting to rebound. So hopefully we'll be going more towards wetter conditions over the next month or two.
Yeah, it's interesting as well because Bob has asked a question. He said that the Bureau has predicted a wetter summer, and that is happening. So a lot of people are feeling that extra rain in their area, and some people aren't. And we've seen the dryness in November, and now we're going to more wet. Do you think that this pattern will happen for all of summer? Bob wants to know.
Again, it's hard to say, and we're still likely to see some of those short-term drivers. If they're in the wrong location and they're strong enough, they will disrupt the La Nina to some degree. As we go through the outlook, you'll see that the forecast that we have suggesting overall it's likely to be wetter over the next 3 months, but no doubt there will be periods when it's drier. But we still think that La Nina will be the dominant climate driver during summer, and so that really increases the probability of above average rainfall.
Okay, and the last one before we get into the next section, and don't forget there are 2 other question and answer sections after this one, so keep sending them in. We'd love to get your questions. Stephen has asked, he's really interested to know the likely timing of above average rainfall for northeast Victoria that is being predicted in relation to a flood risk. Is that something we can answer?
Probably not specifically. As we go through the climate drivers, we'll be looking at them in a seasonal outlook as well as a monthly outlook, so you'll get a bit of a sense there of what's going on in the individual locations. But often we'll see that the things that cause floods are more sort of in the weather timescale. So La Nina makes it more favourable overall for places to see above average rainfall, but then it's usually those heavy, intense rainfall events that will actually cause the flooding.
Okay, so we'll give you a little bit of information around that, Steve. So stay on the line and keep listening for that. So I hope that's given you guys an interesting look at what we've seen so far, and then some questions of yours. But we do have some more opportunities to get your questions answered. Make sure you hit that chat button, send as many in as you want, and we'll get to them if we can. We're going to give you that option after we hear from Fatima. She's got the summer climate outlook details. Take it away.
Thanks, Jordan. So starting the summer climate outlook, I'll be discussing a little bit on the stream flow update and the effect that La Nina normally has on stream flows across the country. Looking at this slide, you see 2 maps with some colored dots on them. The dots represent the stream flow gauges across the country, and the colors, which are orange, dark blue, and shallow blue represents low flow stream flows for the orange color, high stream flows for dark blue color, and near median flows for the shallow blue. Now, looking at the left map, which is the stream flow observation for August to October 2019, you can see a lot of that orange color across the country, which means that we pretty much had a lot of low flows going on during that period of time. With the recent rainfalls and the weather catchments that we have, if you look at the right map, which is the stream flow observation for August to October 2020, Some areas, especially the southeast regions, have improved in terms of their stream flow volumes and have now moved from low flows into high flows and near median flows. Unfortunately, the eastern side of the country, coast of Queensland and New South Wales, the condition is still dry and we are still experiencing low flows. And that goes and is the same for the southwestern part of the country. Now, this chart shows you the observation trend since January 2019. The colors that you see on the bar chart is pretty much the same orange color, meaning low flows, dark blue color, meaning high flows, and shallow blue, meaning near median flows. Now, what you can keep in mind with this one is the higher the orange color bars are, means that we had more proportions of our sites across the country that had low flows. For example, looking at the first box on the left, you can see that for the first 6 months of 2019, the yellow bars are pretty high. Sometimes we had up to 80% of our sites across the country with low flows. However, with the first 6 months of 2020, which is the second box you see in the middle, you can see that those orange bars have dropped significantly, and you can see more of the dark blue bars on the top, which shows that we experience much lower number of sites having low flows for the first 6 months of the year. Now, the last box, which is the box on the right, shows you the recent condition that we experienced in October, showing that the yellow bar has dropped drastically up to 20%, meaning that only 20% of our stream flow locations were having low flows in October 2020. With the weather catchments that we are experiencing and also the persistence that we get in the flow, within average to above average rainfall, we may experience high and medium flows for more of the locations across the country. I'd also like to talk a little bit about the historical impact of past La Nina events on the stream flows. The plot on the top is the monthly Southern Oscillation Index time series. Southern Oscillation Index, or SOI, is an ENSO indicator. So all the blue bars on the top of the plot are when we had La Nina events, and all the yellow bars at the bottom of the plot is where we had El Nino events. I've picked up two major events that we experienced during the past almost 20 years. One is the moderate event of 2000, which is the red box on the left, and the other one is our strong La Nina event that we experienced in 2010 and 2011. On the bottom, I have the stream flow observations that goes with those events. So if you look at the left map, it's showing the December 1999 to January 2000 stream flows. You can see a lot of shallow blue and dark blue almost across everywhere in the country, except for maybe northwestern of Tasmania. That event was a moderate event, and this is what we experienced during that time. The strong event of 2010-2011, which is the right map, you can see that there were mostly a lot of high flows across the country, even in Tasmania. However, southwest of Australia, the flows were pretty low and pretty dry. We also have to keep in mind that the La Nina event of 2010-2011 was accompanied by a negative Indian Ocean dipole phase as well, which enhances the effect of La Nina. And also the catchments were pretty wet during that time before the December to January 2011 event happened. So the take-home point of this slide is that different La Nina events affects the stream flows differently depending on their accompanying climate driver or their strength. Now, what we are forecasting for November 2020 to January 2021 with our moderate La Nina events that we are currently experiencing is that we are forecasting high and near median stream flows, most likely across northern parts of the country and southeastern part of the country, and southwest is still forecasted low flows. The accuracy of our models at this time is moderate to high, so we just have to wait and see how well our models will be doing. I'm going to hand over to Greg now.
Thanks, Fatima. So I'll just follow on with some more outlooks. This time I'll be looking at rainfall and temperature outlooks for the summer period, and similar to what Fatima did, looking at how La Nina influences the rainfall and temperature in particular during the summer period. So these diagrams basically showing a few different weather elements, and what they are is based on historical La Nina events. So rainfall, as an example, as looking back at 14 previous La Nina events across Australia and how rainfall happened during the December to February period in those instances. So on the left-hand side, the green and bluish colours indicate above average rainfall. So we can see, particularly for Queensland, a strong signal or a strong likelihood of above average rainfall during La Nina based on the historical data. And even most of Eastern Australia and also a good proportion of Northern Australia, even extending into Western Australia, typically sees above average rainfall during La Nina. In the middle at the top, a similar picture for maximum temperature. This time the green and blue colours indicate below average maximum temperatures, so quite a strong chance of below average temperatures, particularly over Queensland and New South Wales during La Nina, but also extending over much of the continent. And similarly for minimum temperatures, Northern Australia in particular typically sees below average rainfall during La Nina years, although you'll notice down the very bottom of that map, parts of the southeast actually see slightly warmer conditions, and that may be related to the fact that there's more cloud around and traps what little heat there is in that part of the world. On the right-hand side, we've just got an infographic, just a bit of a summary of other things that are normally associated with La Nina. So more tropical cyclones affecting Northern Australia, increased chance of widespread flooding. Again, that's based on the likelihood of above average rainfall. Heat waves are a bit different than what we normally see. So compared to last year, we're unlikely to see those really extreme days, or certainly as many of those extreme days as we had last year. But typically during La Nina, we do get lower intensity heat waves that last longer, and there can be a fair bit of humidity associated with them. So there's still a significant health risk when they do occur. Also, the earlier rain, so yes, monsoon often starts earlier as well for Northern Australia during La Nina years. And that last little tidbit of information I touched on before is while La Nina is normally associated with above average rainfall, not always. So 12 out of the 18 events since 1900 in Australia have led to widespread wet conditions. Okay, so this is the rainfall outlook for the summer period for Australia. The bluer colour, or the darker blue, indicates the highest likelihood of above average rainfall. So you can see we've got quite a strong signal over Queensland and also parts of the northwest of the country. So northern Western Australia extending into central parts of the Northern Territory. Most of the country, you can see though, sees at least some of that green colour, indicating at least a 60% chance of above median rainfall. Tasmania is really the main area that misses out. But yes, it's certainly the stronger signal for above average rainfall is in Northern Australia, but all of Australia, it looks like, has a good chance of above average rainfall for the next 3 months. Breaking that down into a couple of monthly maps. On the left-hand side, we have December. On the right-hand side, we have January. And we have a very strong signal over parts of northwestern Australia in December. That's likely related to a couple of factors. So the monsoon usually will see a pickup of rainfall, and with quite warm waters off northwestern Australia at the moment, that could lead to some very high rainfall totals. But again, most of northern Australia has quite a high probability of above median rain. It drops off significantly in the southeast in December. Sorry. If we go to January, the signal is certainly less pronounced. Queensland has the greatest likelihood of seeing above average rainfall, particularly in the eastern half, and much of southern Australia is around 50-50. So when you see those white colours, it means it's about 50-50 chance of whether it's going to be wetter or drier than average. For temperature, so this is for the 3-month period again. Most of the country, again, sees a lot of that white, so 50-50 chance of above or below average rainfall. You can see, though, where we do have high chance of below average is indicated by the greeny bluer colours. That's where we're likely to see the most rainfall, so over in northwestern Australia, and parts of the east coast, particularly in the north as well as in the far southeast, may see above average maximum temperatures. Not too much guesswork required with the minimum temperature. Very high chance of above average minimum temperatures pretty much everywhere across the continent. And back to Jordan.
Awesome. Thank you so much. Great information there, team. We do have some time for questions now. Remember, hit the little speech bubble button on the right of your taskbar and start sending them in. We do have this Q&A session, then one more a little bit later on, and we leave plenty of time for questions, so we want to get through as many as possible. Start sending them in. Just a little clarification. Nicole has asked, there is almost no indicators of stream flow maps inland. Is this because they're not tracked or because they aren't big enough? Is that something you can answer for us, Fatima?
Yeah, sure. So mainly the streamflow gauges that we monitor are where we can get good data. They have proper long-term data available. And also in the main inland, it's pretty dry. And it also has to have some sort of economic implication as well as to if it's for irrigation or if it's for dams or water storages. But we are looking into extending our service as much as we can, and we do investigate every site and make sure that proper data is available for monitoring and forecasting.
It's pretty incredible when you think about it, because there are a couple hundred sites, aren't there?
There are 344 sites across the country.
Wow, that's amazing. Long and wide, all the information from the Bureau, there's plenty of it. So Lance would like to know, and I don't know if we can answer this one here, but how much does rainfall have to fall below average to be called a drought? Can either one of you take care of that?
I can have a stab. So drought is officially declared by local government agencies, but certainly there's a strong meteorological component, obviously. And like the drought graph that I showed up earlier, it basically, when it gets to below 90% below average over an extended period, that's normally when we start to talk about drought. There are obviously lots of other factors involved, but it needs to be quite severe. So it's like in some of the top 10% of the lowest rainfall at a particular location.
Okay, excellent. We've also got a question from Jasper, and I reckon this is perfect for you, Mr. Tropical Greg. How do you think the monsoon onset will affect temperatures in the southeast?
Yeah, that's a good question. I certainly can't give you a definitive answer, but what I would say is that there will be a lot more moisture over Australia, especially compared to what we've seen recently with the dry November. So we really need that monsoon to get started to start to draw in some of that tropical moisture. And then often it's basically needing some really good wet systems, some good weather systems that can tap into that moisture. So a very deep front that, reaches into the subtropics, and that can then start bringing down that rainfall. And it's not unusual that it does actually make it all the way down to the southeast. So it really is a combination of having that monsoon, which we expect is probably going to occur over the next couple of weeks, and then the right weather system. Or the other thing that could do it is a tropical low that, crosses the coast of Australia somewhere in the north and then moves down south. So it could happen. Certainly we don't forecast those things, but you want to keep an eye out for anything like a low or a deep low pressure system and a cold front that reaches into the subtropics.
Okay, excellent. Fatima, this one is from Paul. He'd like to know, why does northeast New South Wales have a high likelihood of above average rainfall, but remains forecast for low stream flows? Is this because the rivers are currently very dry?
That's a good question. Yes. So the northeast of New South Wales, the catchments are not overly wet yet. They're still pretty dry. And that contributes to having low flows in that area. And the low flow, because of the persistence in the flow, we expect that because currently we do have low flows and the catchments are very dry, the forecast still showing low flows for that area.
Okay, excellent. So Evan wants to know, how do the current weather patterns or climate drivers compare with conditions present in 2010 or 11 when there was significant flooding that occurred in Queensland? Now, we might be talking about this a little bit later on, but I thought I might just bridge the subject now, see if we can get an answer. Greg?
Yeah, that's a great question. And you're right, Jordan. Well, we will have a slide looking at that. Quickly, though, in summary, the current La Nina is much weaker than what it was at the same time in 2010. A couple of reasons for that. First of all, we did have very much cooler waters and also cooler waters over the Pacific, warmer waters around Australia. The other thing as well, we had a really well-established atmospheric circulation, and that's basically what drives the rainfall over Australia. And one of the other factors as well that's quite significant is that the current La Nina has only been happening since about the end of September. Back in 2010, the La Nina happened quite early, and so it was already declared in July. So it had a lot longer time to really establish. And we also saw quite significant rainfall up to this time of the year back in 2010, whereas obviously we've just had a bit of patchy sort of above average rainfall with the current event. So that really did, as Fatima showed earlier, really wetted up the soils a bit in 2010. The stream flows were much higher. So really the whole continent was primed for rainfall and flooding, much more so in 2010 than it currently is.
Okay, we will stay tuned because we will get really deep in the weeds on La Nina and climate drivers. That is Greg's specialty, so we can't wait to be unleashed upon that. But I have actually a little follow-up on that. Did we think that this one was going to be as powerful? This La Nina was going to be as powerful as the one, because it takes a while for us to understand how strong it is and how it's forming and all that. Did we think it was going to be as intense as 2011?
Yeah, it's interesting. I mean, some of the computer model guidance that we have suggests those sea surface temperatures are likely to be as cold, and we still expect it to increase and strengthen over the next couple of months. So that's one part of the equation. So in that sense, it could be close to the strength that we saw in 2010. But as far as the atmospheric circulation, and Fatima talked about this before, the Southern Oscillation Index, which is the other main indicator we look at, we're still a long way from the strength that we saw back in 2010. And it's a bit debatable whether we're likely to approach that strength. So some of the modelling is suggesting the current La Nina could approach the strength of that one back in 2010. But there's a lot of factors working against it, and including the fact that it did start much later in the year than in 2010, and that Southern Oscillation Index, which is an indicator of the pressure pattern over Australia.
Okay, and before we get back into the presentation, we've got one last question from Caleb. Could tropical systems shift further south due to the warmer waters that are normally surrounding the east coast?
Yes, and they already are. So there's evidence that the change in the water temperature patterns across Australia and across the world basically are expanding the tropics. So it's not just the water temperatures, but the way that it interacts with the atmosphere. And we're already starting to see an expansion of the tropics, and the long-term climate predictions or projections suggest that we're likely to see further expansion. So it's a definite yes.
Okay, excellent question there, Caleb. All right, we do have one more Q&A session coming up at the end of the presentation, so that'll be your last chance to get some of your questions in. Get them to us as soon as you can. We'd love to ask as many questions as possible, so hit the chat bar down in the bottom right-hand corner. It should be blue. That's how you know it's on. And don't put questions in the Q&A. We've only got one person working behind the scenes here, and they're struggling to make sure that their questions aren't in the Q&A, they're in the chat. So make it easier on us and start sending it through to the chat session, and we will give you one last chance to get those all answered by our very knowledgeable experts. All right, Greg, you're going to take us through the climate influences for the upcoming season.
Thanks, Jordan. So yeah, we'll go again looking at the comparisons between that last La Nina. It's something that a lot of people probably have memories of, and it's definitely a worthwhile comparison. And I'll finish off with looking at some severe weather outlook information as well, in particular to do with bushfires and tropical cyclones. So what we see here is a couple of maps showing sea surface temperatures across the Pacific Ocean. Two different periods. On the left-hand side is the latest week in 2020, so the end of November, and we've got almost the exact same period back in 2010, so about the last week of November. And you can see just by the volume and even the magnitude of those cooler temperatures over the Pacific, just how much more mature and stronger the event was in 2010. So that's one of the indicators we use for the strength of a La Nina. So it's normally to do with the strength of the sea surface temperature pattern, as well as that Southern Oscillation Index number. But you can see there's a big difference with the amount of cool water. And similarly, when you look at the warm water around Australia, much stronger positive anomalies indicated by the red colour, so above average warmth in the oceans surrounding Northern Australia back in 2010 than there was in 2020. So that again is an indicator that the atmospheric response to those temperature patterns across the Pacific will not be as strong, and that's currently what we're seeing at the moment in the La Nina of 2020 versus the La Nina of 2010. So it still has a fair bit of work to do, and it's quite late in the season. The natural cycle for ENSO events, or El Nino Southern Oscillation events, means they normally start breaking down during summer, and we're already starting summer. So while the model and observations we're seeing at the moment suggest we will see further strengthening of the 2020, it's probably going to be a bit of a tall order for it to get as strong as what it was in 2010. And another thing that's important with respect to that is that there's usually quite a strong correlation between the strength of the La Nina and the actual impacts it has with respect to rainfall and potentially flooding. So a stronger La Nina normally means more rainfall and a higher probability of widespread flooding. So the Southern Oscillation Index, which we talked about before, it's a measure of the pressure difference between Tahiti and Darwin, and it just basically gives you a good sort of snapshot of what's going on with those atmospheric circulations, so that we saw how the wind patterns over the Pacific Ocean change in response to the ocean temperature pattern across the Pacific. And we like to see it at particular values. Greater than 7 is indicative of La Nina, and you can see that graph on the left-hand side there with a squiggly line. The latest information's on the right, and you can see after it dropped back during November, indicating that weakening of La Nina during the month, it's moved back into the La Nina territory. So as an example, about this time in 2010, that number was up to around 20 or even higher. So we're still a long way off that. So as I said, that's the second main indicator we use for the strength of La Nina. And on the right-hand side, we just have a bunch of international models showing the likelihood of those sea surface temperatures remaining cool enough to be considered La Nina. And all the different bars are from different meteorological agencies around the world, and they're all in that La Nina zone. So basically all the computer guidance we have from all the different agencies suggests we're likely to stay in La Nina conditions at this stage the remainder of summer. So in summary, just looking at the main climate drivers that are influenced at the moment, we do have a La Nina established across the Pacific. It's still weaker than some of the strong ones we've seen, in particular that 2010. It was quite a late developing one, but that is still likely to be the main climate driver affecting Australia over the next few months. And as we said, it's normally associated with above average rainfall during summer. The southern annular mode that often is related to La Nina, and we normally see more positive SAM during La Nina years, and that also historically normally leads to greater rainfall, particularly over eastern Australia. So that's likely to help the likelihood of above average rainfall over eastern Australia in particular over the next few months. Indian Ocean dipole is neutral at the moment. There was a strong negative IOD in 2010, and that enhanced the impacts of La Nina back then. So another reason that suggests not likely to see the same sort of impacts in the current event as what we did back in 2010. And we're also seeing just that background warming of the land and the oceans that also is having an impact on temperatures across the region. Looking at bushfire outlook, so this is a map that's jointly produced by a bunch of agencies, including the Bureau of Meteorology and a lot of fire agencies. And where you see the red areas on that map, that's indicating above average rainfall. So what you can see, most of the country is looking at a normal fire potential. And so we know in Australia, normal fire potential means there's a very good chance we're going to see fires during summer. So we do have a few areas, though, which have even a higher chance than usual. So those areas need to be obviously well prepared for what's going to happen in the next summer. And you can see a lot of New South Wales is seeing above average fire potential. And that's because that rainfall that they saw earlier in the year has actually produced a lot of grass, and then that has the potential to dry out over the coming months and be fuel for potential bushfires. It's a different story over in the west, which is the other area that has those areas of above average fire potential, and that's because it's been so dry there. So the bush over there has basically had a long time to dry out, and it's ready to burn now when the conditions and an ignition source becomes available. Tropical cyclones, so we touched on it earlier. Tropical cyclone activity across the Australian region is normally higher during La Nina years than non-La Nina years. So the number down the bottom, which is the main one to look at, is that we have a 66% chance of more than average tropical cyclones across Australia during the cyclone season, which goes till the end of April. All of the regions, so there's a northern region, an eastern region, and a western region, have a greater than 50% chance of above average cyclone activity. Forecasting for tropical cyclones is not advanced enough to say where we're likely to see those cyclones or of what intensity, but overall we're likely to see more cyclones this year than what we do in an average year. And obviously it only takes one cyclone to really cause major damage and disruption in any one zone anyway. Overall, we have seen a reduction in tropical cyclones across the Australian region, but it's during times of La Nina when we are most likely to see average or above average numbers. So in summary, as far as the main severe weather issues for Australia, we talked about bushfire activity, and while most of the country is likely to see a similar likelihood of significant bushfire risk in the summer, we're seeing above average in parts of Western Australia and New South Wales. Heat wave, similar, we touched on that as well. We're not likely to see those really high number of extreme temperature days like we did last year, but we still do see heat wave activity during summer in La Nina. Flooding becomes more of a risk just with the likelihood of more rainfall than usual. The drought, we are likely to see some improvement. Keep in mind, though, that some of those places have been in drought since January 2017, as we touched on earlier. So it's not going to be just like 1 or 2 months of good rain. They're going to need sustained periods of above average rainfall. And even if it rains really well for the remainder of summer, there'll be some periods that have started so dry that even they will probably still be in borderline drought conditions. and tropical cyclones as well. So Northern Australia needs to be prepared now. We're already in cyclone season, which started 1 November, and La Nina is normally associated with more than average numbers of cyclones. Over to Jordan again.
Awesome. For our last Q&A session, you've still got time to get them in. Just hit the chat bar in the bottom of your screen. You can see a picture of it on the screen now. That's what it looks like when it's activated, and you can start sending us any question that you have before we wrap up at 3 o'clock Melbourne time. So jumping straight into it, Ray would like to know, and this is probably perfect for you, Greg, what are the indicators of when cyclone activity may commence?
So it's a good question. There's a few things you want to look at. So we're obviously in the cyclone season, so that increases the chances greatly. But what we really like to see is a monsoon trough developing across Northern Australia. That is often a focus zone for tropical lows that can go on to develop then into tropical cyclones. We're starting to come into a period now where a lot of the factors are starting to line up. So there's a Madden-Julian oscillation in the Australian region that's often associated also with tropical cyclone activity. So if we start to see a monsoon trough developing across Northern Australia, that's the time when you really need to be concerned. But the Bureau is always monitoring these things, and we have outlooks and warning pages readily accessible at the Bureau website. But certainly we're coming into a period now where the tropical cyclone risk will start to rise.
Excellent. Thank you for that. Vlad would like to know, does the water temperature difference in the Coral Sea bring being warmer than in the 2010 model have any influence on the La Nina effect?
It's part of the whole equation. So again, we would normally expect to see probably warmer waters during La Nina across the Coral Sea. It's taking its time to really warm up. So again, it's indications that the La Nina that we're currently in is not as well developed as what we saw back in 2010. And that in turn has other impacts. So with cooler waters around northeastern Australia, it might mean that cyclone activity might be reduced slightly, and rainfall also is probably going to be a little bit lower than what it might otherwise be.
Okay. Sue has asked, what are the implications for forecasting of the cyclone activity in the southwest Indian Ocean? Does that have any effect on us here?
Again, that's still part of the region. So Australia's western region for cyclone monitoring goes out to 90 east, which is well off the West Australian coast and into the South Indian Ocean. Right across the Australian region, La Nina is associated with above average cyclone activity. So we always need to be wary of that. There's a good chance we'll see above average cyclone numbers. And those are the sort of cyclones at the right time. They can develop and move their way towards Western Australia, which is the most prone part of the country for cyclone impact. So between about Exmouth and Broome, we see more cyclone impacts there than anywhere else in Australia.
Okay, so Dean has asked, when it indicates higher than average rainfall in South Australia during summer, what does this mean when there is usually very little rain?
Yeah, well, that's a good point. So there are some regions where above average may still be quite a small number. So we don't actually forecast the amount of rainfall in the maps that you saw, just talking about the likelihood of above average. So say parts of Western Australia, it's a classic example, as well as South Australia. They're actually quite dry during the summer months with their Mediterranean type climate. So even if it's above average, it doesn't mean that they're likely to see big rainfall. For some places, they could see 20, 30 millimetres during summer, and that will be above average.
Okay. Speaking of SA, we've gotten a question that's come through from Tanya. She doesn't think she's heard much about South Australia mentioned. Do you classify South Australia as Eastern Australia, or did we just not discuss it a lot?
That's a good question. I probably normally think about it as southeastern Australia, but that's probably more so from an Adelaide and the populated parts of Australia. It's quite an interesting one because, like Western Australia, it's not necessarily impacted as much as parts of Eastern and Northern Australia during La Nina, so we don't see such a strong signal. So I think for a lot of the outlook information, particularly with rainfall, it was sort of more in that 50-50 zone than those strong rainfall signals we saw in parts of Northern Australia and Eastern Australia. So it probably depends on quite a few factors and where you're from. But yeah, I sort of throw it more into the eastern side. I mean, because Western Australia, as you know, it feels like it's half the country anyway. So that's the west, and everywhere else is pretty much the east.
Okay, but we do care about you, South Australia. We love you very much.
Wonderful people.
Excellent. I did live there for a bit. Lovely people. So our very last question, though, we have a one from Charmaine. I think this is really interesting. Are cyclone intensities in Queensland expected to be higher with the current drivers this season, or is it just more?
Yes, it's more. There's no real indications in any of the data that we look at that there's been much of a change in cyclone intensity over pretty much all of Australia. And La Nina really doesn't give us much of an idea about intensity. So all we're saying with La Nina is that there is an increased chance of above average cyclone activity across the Australian region.
Okay, well, unfortunately, that's all the time we have for today. But if you joined us late, Greg, could you give us a quick summary of what we went through and where you can find more information?
For sure. Okay, so we started off with a quick little recap of spring, and as most people are aware, it was dry and warm for the most part. The stream flows were also relatively low. La Nina is established across the Pacific Ocean, and we're in a moderate sort of strength event at the moment, potentially becoming stronger over the next couple of months. And La Nina is normally associated with above average rainfall during summer over Australia. And as a result, higher stream flows are often the case as well over Eastern Australia in particular. Stream flow outlook indicates above average flow over most of Eastern Australia and below average over Southern WA. And that's a product of the fact that they don't normally see as much rainfall in summer. They're not as heavily impacted by La Nina, and they're also starting from very dry conditions in the lead up to summer.
Awesome. Thank you, Greg. You've got some more information as well.
Yeah, I guess just following up, and this will be in the information that we send out to everyone, so you don't have to jot these down at the moment, but there's a whole lot of information on the Bureau's website. So pretty much everything we've covered has a specific website for it. So there's tropical information, the general climate information, a whole lot of stream flow as well as storage information. And we also have a whole bunch of educational videos as well as educational literature as well. So if you like your weather and climate, go to some of these sites and I'll keep you entertained for days.
It does, doesn't it? Don't worry if you haven't written down those links, because we send the presentation material around with the recording of this event. So you'll have all of that ready at your fingertips. If you'd like to get Bureau information on the platform of your choice, why not connect with us on social media, our blog or our excellent BOM Weather app. And you can subscribe to receive updates direct to your inbox from the Bureau about everything Greg and Fatima have talked about today, or information on upcoming webinars. So if you've been following the Bureau, you would have seen that we've just released our State of the Climate report in conjunction with the CSIRO, and it draws on the latest monitoring science and projection information to describe long-term changes in Australia's climate. So that's what our next BOM webinar is going to be about. It'll be a deep dive on this report with the authors of it from the Bureau and the CSIRO. This only happens every 2 years. So register now to avoid missing out. The link is in the chat, or visit bom.gov.au/webinars to register. We'd love to have you guys come by. So that brings us to the end of today's webinar. For questions we didn't get to, please email helpdesk.climate@bom.gov.au. A big thank you to Greg and Fatima. We appreciate your time in developing the content and sharing your knowledge with us. And to you, thank you for tuning in and joining us today. We hope you enjoyed the session, and we do hope you'll join us again next time. If you'd like to continue the conversation, please use the hashtag BOMWebinars in your social posts. As mentioned earlier, this session has been recorded, and the video along with the presentation material will be ready soon, so watch your inbox. Finally, finally, but most importantly, we want your feedback. It's our aim to bring you the highest possible quality webinars, but we can't do that unless you share your experience with us. So once this closes, a short survey will pop up on your screen, and we'd be very grateful if you could complete that anonymously for us. Once again, thank you for your time. We look forward to seeing you again soon. Goodbye.